Hello guys, how are you? I hope you're doing well. First of all, I want to say sorry for the previous video that we uploaded on the channel. It was not working very well, but this one is going to be good. So, we planned this with all the other teachers and along with Miss Susan to create something very good for you guys because we have lost so many lessons and topics and we've lost so much time as well. But this project is going to help us getting back on track and it's going to help us to catch up all the lessons that we've missed. And even though that it's a holiday, but I'm hoping that you guys stay home, be careful, take care of take care of yourselves and take care of each other. Stay clean, please, because we don't want you to get sick, do we? Now, what I'm going to talk about is the importance of the physical properties, even though that we talked about this in school, but we're going to have a quick review and then we're going to talk about one or two more new topics. Stay tuned. So if you want to be with me, go to your book, Unit 5, Chapter 1, Lesson 1, The Importance of Physical Properties, and let's catch up. So, matter is anything around you. For example, last year we said that we talked about matter. We said matter is anything around us that takes up space. For example, if you are in your bedroom right now, the bed is taking up space, so that's a matter. If you have posters around your room, they're also matter. So anything around you that takes up space is called matter. We can differentiate the matters between each other by their physical properties and chemical properties. Since your book is only talking about the physical properties, so we are just going to stick with that. Some physical properties like what? Like the color, the taste, the hardness. For example, I have a picture right there for you. If you look at them, for example, we have a balloon. Balloon is different from a bell by their shape, by their function, right? So you can differentiate between these matters that you have in the picture, like a Coca-Cola, milk, bell. For example, Coke tastes very much different from milk, right? So we can differentiate the matters based on their physical properties and chemical properties, and some physical properties such as color, taste, or hardness. Okay, the first physical property I'm going to talk about is mass, but I'm going to mix it up with weight because they are related to each other. So I still remember the day I explained this. I said if a scientist asks you, can you tell us or can you tell me how much do you weigh? You cannot say I weigh 50 kilograms or I weigh 40 kilograms, 55 kilograms, 60 kilograms, or any different number, because that is scientifically wrong. If you want to know your weight, you shouldn't say I'm 50 kilograms or 25 kilograms or 30 kilograms. Scientifically, this is not right. If I want to know my weight scientifically, I have to multiply that number that I just said by the force of gravity, and force of gravity is a number that will not change unless I go to space, because the higher I go up in the sky, the less force of gravity I will have. So, the number of force of gravity is 9.81, and that number is not going to change unless I go to space. Now, if they ask you what's your mass, you can say I'm 45 kilograms. For example, right now I'm 58 kilograms. So if they ask me what's my mass, I'm going to say I'm 58 kilograms. And as you can see, by 2 stars I wrote them for you. Mass is measured by kilogram or gram, but weight is measured by Newton. Because Newton was the one who discovered the force of gravity. Do you remember who Newton was? The guy that was sitting under the tree and then the apple fell down on his head? Yeah, that's Newton. So mass is measured by kilograms or grams, but weight is measured by Newton. So whenever a person asks you, can you tell us scientifically what's your weight? You will say, just a second, let me know my mass. My mass is 45 kilograms, for example. I'm going to multiply that 45 by 9.81, which is the force of gravity, and then I'm going to have my scientific weight. Now, if you look at the picture, I have the same person, but at one time they're standing on Earth, at the other time they're standing on Mars. So, if you look at the mass, their mass is still the same, 50 kilograms, 50 kilograms, but the only thing that is changing is the weight. That's because In Earth, or on Earth, we have the strongest force of gravity, but on Mars, we don't. So this is why the mass is not going to change, the mass will stay the same, but the weight is going to change because of the force of gravity. Now, volume. Sometimes I wonder, how can I measure the volume? For example, we said, yeah, a matter takes up space, right? I want to know the amount of space that the matter is taking up. So, in order to know that, I'm using volume. We can find out volume for liquid, for gas, or for solid as well, because we have 3 different states of matter, remember? So, let's see how we can measure the volume of a liquid. Now, do you see that picture right over there? Okay, that's a cylinder that we have. And it has numbers on. As you can see, 5, 10, 15, 20, 25 milliliters. And I'm pretty sure if any of your family members have ever tried to make a cake or something, they've used a glassware or a type of plastic that has numbers on. Basically, by those numbers, we can understand the volume of a liquid. We're going to pour the liquid inside, and then the liquid is going to stop on a number. We're going to read that number, and that number is going to tell us the volume of that liquid. So, I have a question right over there. It says how to measure a liquid's volume by using a graduated cylinder. And this graduated cylinder is a clear tube with numbers on. Okay, so that was how to measure a liquid's volume. But this time I'm telling you how to measure a solid's volume. Well, we have 2 types. Sometimes the solid matter shape is very organized, like a box that you see in this picture. They have height, they have length, and they have width. By those 3, we can find out the volume. We have a rule, which I wrote in orange. Volume equals to length multiplied by width multiplied by height. So if we have the height, the length, and the width, we can actually find the volume of the organized matter. Now I gave you an example. I said measure the volume of a box if its length is 15 centimeters, and if the height is 10 centimeters, and if it's the width is 5 centimeters. So if you have all the 3 numbers, what you have to do is just multiplying all 3 of them so you can have the matter volume. But remember that this is only used for the organized shaped matters, not the unorganized ones. So please do it and write the result next to it. Now, for the second one, which is the unorganized or the not organized shaped matter, we're going to bring a cylinder, we're going to fill it up with water, then we're going to write the number the water stopped on. For example, in the first picture it stopped on 150. Then, for example, I'm going to bring a rock and I'm going to put it inside the cylinder. I'm going to check if the water is going to rise. And apparently it did. So, it was 150 before, but now it's 180. The difference between the 150 and 180 is 30 milliliters. So this means the volume of the unorganized shaped matter is 30 milliliters. Now, another physical property is density. Density is another physical property, and it's also telling us about the amount of matter in a certain volume, meaning the amount of particles that we have. If you look at this picture right here, we have so much particles in one box, and we don't have much in the other box. Now, if I know mass and volume, I can easily find out about density. Density equals to mass over volume. I'm going to divide them. For example, what's the density of a matter if the mass is 10 grams and the volume is 2 cubic centimeters? If I give you both the numbers, how can you find out the density? But remember, I also gave you the rule upstairs, which is written in orange. Now, the more particles we have, the denser the matter will be. But the less particles we have, the less dense the matter will be. So guys, even though that I'm talking about these topics very quickly, it's just because that we already learned this in school. This is going to be like just a quick review. Now guys, this is the new topic that we will talk about. It's really easy and don't freak out. So most of the objects that you guys see around you, They're not pure substances, they're mixtures. I'm pretty sure you've all did this at home. You bring a glass of water, then you put some sugar inside. Have you ever wondered how this happened? Well, let me tell you. A mixture is a combination of two or more different kinds of matter. Now, when you mixed the sugar with water, you mixed two different kinds of matter. We have three states of matter, remember? Solid, gas, and liquid. So, you combined two different states of matter, which was the sugar, the solid, and the water, the liquid. You mixed them up, and there you go, you have a mixture. But sometimes the mixtures, meaning the matters, keep their physical properties. How? I'm going to give you an example here. So, imagine that in the picture, instead of sulfur, it's written sugar. So if I mix sugar with iron fillings, by the way, iron fillings is like they're small pieces of iron. Imagine I bring a big piece of iron and I'm going to break it down into very, very, very small pieces, okay? Then I'm going to mix those small pieces of iron with sugar. How can I be sure that the iron didn't lose its physical property? By separating them. I'm going to separate them from each other by bringing a magnet. I'm going to put it over the mixture of iron and sugar, and I'm going to see if the iron is going to stick to the magnet. If the iron stuck to the magnet, this means that the iron didn't lose its physical property, even though that I broke it down into many small pieces. And as you can see in the picture, thankfully, the iron didn't lose its physical property and it stuck to the magnet. And this is called a mixture. And when you try to mix sugar with water or salt with water, you will have a solution, because that sugar is going to dissolve in the water. Now guys, this is the last slide and this is the last topic that I will be talking about. Hopefully you got some information. So, what is solubility? For example, you bring salt and you just put it in water, then it disappears. What do you call this? This is the solubility of the salt that dissolved in the water. So, the answer says it's the ability of a matter to dissolve in another matter. For example, salt can dissolve in water, but sand can't. As you can see, and you can even try this, you just bring a glass of water, just put some salt in it, and after a while the salt is gonna disappear. By disappearing, this means that the salt has the ability to dissolve in water. But if I bring mud, okay, just go out of your house and just bring some mud, put it in the water, stir it for a while and shake it, that mud is not going to dissolve because its solubility is not that good. So if a matter is able to dissolve in another matter, we call this solubility. So this means, just like in the picture, the salt and water they both have a very high solubility, but the sand and water, they don't. So this is what solubility is. It's the ability of a matter to dissolve in another matter. It's the ability of the salt to dissolve in water. So this means that the salt and water, they have a very high solubility. Now guys, we came to the end of the slide and the end of the topic as well. I'm pretty sure that you guys got some information, and the topics that we learned before the holiday started was just a review for you. And these two topics that I talked about, they're pretty easy, so don't worry. I actually miss you guys, and I hope that you all are doing well. But please do not neglect these topics that we talked, because when you come back to school, it's gonna be like a quick review, and you're just gonna get so much more information. I hope that you all stay safe and sound, and I miss you. Hope you listened very well.